All right, so here we are going to do LeetCode number 1266, visiting minimum time visiting all points. So this is an easy problem. So essentially it says on a 2D plane, there are endpoints with integer coordinates, points I, meaning for each point in the array, there are two, values on 2 dimensions, xi and yi. It wants us, so if we draw this out on a graph, on a 2-dimensional plane, essentially all it's saying is we have a bunch of points. What it wants us to do is return the minimum time in seconds to visit all the points in the order given by points. And there are a few rules with this. In 1 second, you can move either vertically by 1 unit, or in 1 second, you move horizontally by 1 unit, or in 1 second, you can move diagonally square root of 2 units, meaning 1 unit over, 1 unit vertically. So right away, we can see, obviously, the fastest way to travel is diagonally, because we can go to square root of 2 speed, which is, essentially 1.414, which is about 41% faster. So, yeah, where we're given this array of points, they're in an order, like this one, and then this one, and then this one, and this one, and this one, and we essentially just have to calculate the fastest path going between them in all order, in the order. Now note that path isn't directly line to line, rather we have to follow the rules they said. So let's say if this is, at height 2, and x-axis 1, and let's say this is at -3 height and -2 width, or -2 on the x-axis, then we can't just go straight from -2, -3 to 2, 1. Rather, we would have to go from -2, -3. Actually, we can't do that. That's not along a directly 45-degree angle. It's not a true diagonal. We would have to go, let's say, up 3 over 3, which in our case would be from -2, -3 to 1, -2. So we could go like this. That's a diagonal. Like this. That's a diagonal. And then we can go up 2. So, yep, we go 3 diagonal, and then up 2. So that's just an example of how we'd have to find the fastest path, I guess, to kind of prove what the fastest path is. Again, let's have another graph. Let's say we have any 2 points, and we have n height and p width. We want to go the maximum number of diagonals we can, and then the rest will just go vertically or horizontally in our case. So we could say that p is some amount longer than n. We could say that p is equal to n plus m, in which case really the width is m plus n, and the height is n. And what that tells us is we can go diagonally, square root of 2n units, such that the height right here is n, the width right here is n, and then a diagonal, using Pythagorean theorem, is square root of 2 times n. So we would go essentially n units horizontally and vertically in one move, and that would only take n time, and then the remainder we'd go m units over. And what's interesting is, even though we went diagonal, it still only takes n time. We went n time plus m time, and n plus m just happens to be the length of p, the length of the longest side. Now whether, so yeah, I mean, that's a really fascinating conclusion. No matter what no matter what we do, we're just going to take p time. We're just going to take the longest length time. Now you might ask, well, what if one of these values is negative? What if we're in this quadrant or in this quadrant, or it starts over here and goes over here? It actually doesn't change anything, since negative coordinates don't really change the length of one of these values. These values are just the absolute value of the coordinates. So in any coordinate, you can draw this out for yourself. In any quadrant or configuration, we're really just going, the time we're going to have to take is just the longest path. So really, we can start coding this. It's pretty easy. All we have to do is go through iterate through each step in this array of ordered points in this sequence, and look at the current point and the next point, and just calculate the time it takes. And we know the time it takes is just the length of the longest side between them. So in this case, the longest side between this point A and this point B is simply going to be the y-axis, the length of the y difference, which is going to be 5 in this case, because the width is only 3. And same thing, B and C, we're going to look, it looks like the y length is longest, so we're going to calculate the y length, just return that as the time. So the question that's asked us, we're going to be doing this in TypeScript, and it's called function min time to visit all points. That should be capital P, all points. And it takes an input, which again is a points array, and really it's like an array of arrays. And they give you a type of, the type that they provide is the following. It's essentially like an array of arrays of numbers. We can actually change the type in TypeScript in the LeetCode execution engine and still have it work fine, because it really just executes the transpiled JavaScript. So to be more clear, we're actually going to define a type called tuple. Implicitly, it's just, in the name, it's just a tuple of numbers. And we're going to define it as an array of length 2 that contains just numbers. And we are going to say that points is an array of these tuples. And that just kind of makes the data type a bit more clear than this, because it shows that the inner array of each index in the outer array is of length 2, and each item in that length 2 array is a number. And this function is going to return a number. It's the time. Okay, so we aren't going to fill out this function yet. Rather, we're going to write a helper function to calculate the maximum time to travel between 2 points. Not for all the points, but just for 2 points. Sorry, not the maximum time, the minimum time. So we're going to create another function. We can just call it time. And it's going to take 2 tuples. One, we'll just call x1, y1. And the other tuple we'll call x2, y2. Now, most people know this nowadays, but this is using kind of the newer ES6, ES 2015, or TypeScript syntax. You can essentially do this thing called destructuring, where you can put the variable names inside of like an array value. And if the data passed into this function as an argument is of a type array with at least two variables in that array, these 2 values in that array, the first value will get set equal to this variable name, second value gets equal to this variable name, and if the second argument is another array, again with 2 values, the first and second of those values of the second array will get mapped into the x2 and y2 values. So we just want to calculate the time to go from this point to this point in the fastest way possible. Again, maximizing the amount of diagonal space we take. Again, using what we determined up here, the time is literally just going to be the distance of the longest side between these 2 points, where the 2 possible sides we're looking at are the horizontal side and the vertical side. Or more formally, well, yeah, I guess we could say the x-axis or y-axis. So we're going to say that the x-length side, the horizontal side, in our 2D plane, is going to be simple math here. The absolute value of x2 minus x1. I should have written those as full scripts, not subscripts. And y length. Usually people say let again and do separate statements, but in JavaScript you can actually put them all under one let statement, just separated by a comma when defining new variables. So I'm going to do that to save us some time. And we want to calculate the longer of these sides. So we're going to say longer, we're going to use the ternary operator if the length of y is greater than the length of x. Oh, you can't see this right here. Yeah, length of y is greater than length of x. The longer side is going to be the y length. Otherwise, it will be the x length. And we're just going to return that longer value. So now, we just need to iterate through each of the array pairs in this points array and calculate the distance between them and sum up all those distances between all of the pairs. So we're going to create a function called sum, initialize it to 0. We're going to iterate through all of these points for let I is equal to 0. I is less than or is less than points.length minus 1, because when we're on the last point of the array, we don't want to be calculating the distance between that point and the next point because there is no next point, and we're going to get an index out of bounds error. So we got to stop iterating at the second to last point. So we'll calculate the sum. We're going to calculate the time between the current point and the next point. So really all we got to do is time of points sub I, or index I of points array. Turn sum. So let's check this for syntax errors. That looks right, that looks right. We define the type here. That was just the initial type they gave. Again, we can put whatever type we want in our TypeScript programs. And it'll still work in LeetCode because LeetCode is going to transpile it. It's not going to look at the types. Number, we have our ending bracket right there. And we have a helper function. It's called time, so we invoke it here. We have two tuples, x, y. I mean, this right here we should really write as x2, y2, but I think you understood that. X length is yup, ternary operator. Yeah, we don't really need semicolons, but yeah, this will work. If you run this in LeetCode, it will be a correct solution, and it is listed as, I think it's listed as fast. It says top 96%. Well, I guess it's, I guess everyone uses the solution. When I run at different times, sometimes it says it's faster than a lot of solutions, other times it says it's not. Other times it says it uses more memory, other times it says it's not. So I'm not really sure what the true answer is there. There might be a better solution actually, but we'll go into that in another video if there is a better one. But yeah, that's it for now.